Hello everyone, welcome to IB Math Solution. Today we will be studying about intersection and union. So when we talk about sets, let's suppose we have three sets. Set A is 1, 3, 5, 7 and 9. Set B is 4, 5, 6 and 7. And set C is 2, 4, 6, 8 and 10. So when we say intersection, intersection means common elements in two sets, two or more sets. And the symbol for intersection is this. So when we say A intersection B, then it means common terms that are present in A and B both. So if we talk about 1 is not present in B, 3 is not present in B, 5, yes, 5 is present in B, 7 is present in B, and 9 is not present. So A intersection B will be a set containing 5 and 7. Now, talking about union. Union means the elements that occur at least once in either of the sets. So the symbol for union is U. So when we say A union B, then it means that it is a set containing all the elements of A and B once. That means 1, 3, 5, 7, 9 and 4. 5 we have already written, then 6 and 7 we have already written. So this is the set that is appearing at least once in either of the sets. So A union B is this set. Now, disjoint sets or mutually exclusive sets. What do we mean by these sets? Disjoint sets or mutually exclusive sets are those which sets which don't have any element in common. Suppose we have set A and C. Now, there is not even a single element that is present in both A and C. So if one is present here, one is not present in C. 3 is present in A, 3 is not present in C. 5 is present in A, 5 is not present in C. Similarly, 2 is present in C, 2 is not present in A. Therefore, we can say there is not even a single element that is present in both of them. So A intersection C will be an empty set, or we can say when we have disjoint sets or when we have mutually exclusive sets, then intersection of those sets is an empty set. Now let's move on to exercise 2b and solve some question. Question 1 says find A intersection B and A union B for all these. So A subpart 1 is A intersection B. Now the term that is common in both A and B is 9. 9 is here, 9 is here as well. So A intersection B is a set containing element 9. Now A union B is 6, 7, 9, 11, 12, Now the elements from set B that are not in set A: 5, 8, 10 and 13. 9 we have already written, so, and in a set there is no duplicacy. Part B, A intersection B is the common terms 1, 2, 3, 4, 5, 6, 7 and 8. So it will be an empty set, or we can say this. Part 2, A union B. A union B will be 1, 2, 3, 4, 5, 6, 7 and 8. Part C, A intersection B 1, 3, 5, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, we have 3, we have 5, we have 7. So A intersection B is 1, 3, 5, 7. And A union B is 1, 3, 5, 7, 2, 4, 6, 8 and 9. Similarly, part D, A intersection B is 0 is not there, 3 is not there, 5, yes, 5 is there, 8 is there, 14 is not there. So A intersection B is 5 and 8. A union B is 0, 3, 5, 8, 14, 1, 4, 11 and 13. Let's move on to the next question. Determine whether the sets are disjoint. So we know when the sets are disjoint or mutually exclusive, the condition for disjoint or mutually exclusive sets is A intersection B must be equal to empty set. So this is the condition. Now solution. Part A. Do we have any common element in A and B? 3 is not common, 5 is not common, 7 is not common, 9 is not common. So part A, A intersection B is an empty set, or we can say A and B are disjoint sets. Part B. So P intersection Q, do we have any common term? 4 is not there, 9 is not there, but 10, yes, 10 is there in both of them. So P intersection Q is 10. Therefore, we can say P and Q are not disjoint. Let's move on to the next question. So the question says, let A be equal to even numbers between 20 and 30. So between 20 and 30, what are the even numbers? 22, 24, 26 and 28. B is odd numbers between 20 and 30. So that will be 21, 23, 25, 27 and 29. C is composite numbers between 20 and 30. So to know the composite numbers, first we need to know what are the prime numbers. Prime numbers between 20 and 30 are 21 is not a prime, 22 no, 23 is a prime number, 24, 25, 26, 27 are not prime, 28 is not prime, 29 is a prime number. So if these two are prime numbers between 20 and 30, then composite numbers are 21, 22, 23, not 23, 24, 25, 26, 27, 28. 29 is prime number, so it won't be in the composite list. Now, which pair of sets is disjoint? Justify your answer. So, part A says, which are the two sets that are disjoint? That means, which are the two sets which do not have any element in common. So, A intersection B is an empty set. We can see 24 is not in B, 24 is not in B, 26 is not in B, 28 is not in B. Or rather, we can say A is a set of even numbers and B is a set of odd numbers. Therefore, they will never intersect. They will never have common elements. Therefore, A and B are disjoint. Because A is even and B is odd. Part B says, list the elements of A intersection C. So A intersection C will be 22, 24, 26 and 28. Is A a subset of C? Yes, we can see all the elements of A are present in C. 22 is present, 24 is present, 26 is present, and 28 is present. So yes, A is a subset, proper subset of C. That is our answer. Now part C, find number of elements in B union C. So first we need to find B union C. That will be 21, 23, 25, 27, 29, and then 21 we have already taken, 22, 24, 25 we have already taken, 26, 27 we have already taken, and 28. So this is B union C. Now the number of elements in B union C is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 9 elements. So we have done this question. Let's move on to the next question. Determine whether each statement is true or false. Explain your answer. If R and S are two non-empty sets, then R and R intersection S is an empty set. Then R and S are disjoint. This statement is true. Now, why? We know if there are no common elements in A and B, then A intersection B is an empty set, and A and B are disjoint. Part B says, for any sets A and B, number of elements in A intersection B is less than or equal to number of elements in A, and number of elements in A intersection B is less than or equal to number of elements in B. This is also true. Now, why? Because we have certain number of elements in A, we have a certain number of elements in B. Now, the intersection of A and B will always have elements no more than A or B. So, if we say there are certain elements that match in both the sets, the number of elements that match can never be greater than the number of elements in A or B individually, right? We know that number of elements in A intersection B can never be greater than A or can never be greater than B individually. Therefore, we can say number of elements in A intersection B is either less than or equal to number of elements in A. Similarly, number of elements in A intersection B can never be greater than, or we can say will always be less than or equal to number of elements in B. Part C, if A intersection B is equal to A union B, then A is equal to B. Now, the condition is A intersection B is equal to A union B. And the question is asking, is A equal to B? Suppose we have a set A that is 1, 2, 3. We have another set that is 5, 6 and 7. Now, A intersection B is an empty set. However, A union B is 1, 2, 3, 5, 6, 7. Now, in this case, we can see A intersection B is not equal to A union B. But we need a condition where A intersection B has to be equal to A union B. So let's take another example, example number 2. This was example number 1. So what can be that set? Let's say A is equal to 1, 2, 3. B is equal to 1, 2, 3. Now what is A intersection B? Intersection B will be 1, 2, 3. And A union B will be 1, 2 and 3. So can we say A intersection B is equal to A union B? Yes, they match. In this condition, can we also say that it was only possible when A is equal to B? Therefore, if A intersection B is equal to A union B, we can say A is equal to B. This is true. This is true, not false. That's it for the exercise. I'll see you in the next session.